Hello. Today's lesson is on radians. It's so exciting. This is what we get to talk trig a lot. Anyway, it says, in your own words, what is a radian? Well, a radian is an angle measure. The measure of an angle. Where the intercepted arc is the length of the radius. Okay, so here's the radius. I'm going to measure it, and I'm going to take that length, and I'm going to wrap the length here. So the length of those blue lines are both r, the radius. Okay, this is the intercepted arc. Here's the angle. The measure of that angle is 1 radian. Okay? And the thing that's really nifty about radians, it's the same with degrees. This is about 1 radian is almost about 57 degrees, give or take small change. Okay? A little bit bigger than that. But the angle's always the same. So if I come over here and have a teeny tiny circle, isn't that neat? And draw its radius and draw its arc. The angle here is the same as that. Okay? Make a teeny tiny one. Oh, it won't let me. That's fun. Yeah, we'll get rid of that. Oh, it did work. Okay. Its radius, arc length. And why is that? Well, if you think about it, what's the circumference of a circle? Circumference is 2 pi r. Okay? So 2 pi r, pi is 3.14, so that's 6.28 r. So there's 1 radius, 2 radius, 3 radius, 0.14, 4, 5, 6, and here's your 0.2. Okay? We've done this before with wiki sticks, and we have kids take their wiki stick and make it that long, and you wrap one piece here, and another piece here, and another piece here. And it goes around 6.28. No matter how big the radius is, it still takes 6.28 of them to go all the way around the circle, hence 1 radian. All right? It's nifty. All right, if we're going to convert from degrees to radians, think about it. From here to here, well, all the way around the circle is 2 pi. So halfway around the circle, so here's half, is pi radians, or 3.14 radians. It's also 180 degrees. So if I'm converting from degrees to radians, so I have degrees, I'm going to multiply by pi radians per 180 degrees, and they cross out. And your answer's in terms of pi, because it's exact. In reverse, if I have radians, pi radians, and you're going to multiply by 180 degrees per pi radians, these cross out and your answer's in degrees. Okay? So I have 135 degrees. I want it in radians. So I want pi radians on top, 180 degrees on the bottom, and you get 135 pi over 180. Does that reduce? Probably. You smart people out there. Is 3 pi over 4. Okay. You multiply this times pi over 180, and you get 540 pi over 180. 540 divided by 180 is 3 pi. I have negative 270. We've got to talk about direction here in a minute, but it doesn't matter. So 270 divided by 180 is 3 negative 3 pi over 2. To do it in the other way around, you're going to multiply by 180 over pi. Here they cross out, and you get negative 90 degrees. Here you get 180 divided by pi, and you get 360 divided by pi, which is a weird number, and we don't ever do that. Okay, let's do the math. 360 divided by pi is 114.59 degrees. This you're going to multiply by 180 over pi. The pi's cross out. 2 goes into that 90 times 9 is 810 degrees. It's a big angle. Okay? So you got to learn to convert them. All right, standard position. Angles have an initial side and a terminal side. The terminal side rotates, okay? The initial side is fixed. So this side is fixed. This one rotates. And then you have a vertex, okay? If you put the initial side on the x-axis and you rotate the terminal side counterclockwise, that causes your angles. So this angle's a little bigger than 90 degrees, right? Because here's 90. That would be 90 degrees. This is 180 degrees. This is 135 degrees. All right. Positive angles go this way. Negative angles go backwards. Angle A, alpha, and beta, they end up at the same spot. They're called coterminal. And once and go around twice, that's also coterminal. Okay, sketch the following. Pi over 3. Now remember, from here to here is pi. So I need a third of it. Okay, a third. If you multiply it times 180 over pi, that's 60 degrees. So it's right here. Okay. Today that's fine. Make those conversions. All right. This angle here is pi over 3. That equals 60 degrees. Because you know how to draw 60 degrees. This is times 180 over pi. These cross out. And you get negative 4 is what? 45? So negative 45 degrees. Remember, here's the terminal side. I mean the initial side. The terminal side rotates down 45 degrees, or negative pi over 4. I want you to start thinking in radians, not degrees. All right, that's the goal. 225, I don't know, that's 180. If you subtract 180, what do you get? 45 degrees. So it's 180 plus 45 more. So it goes like this. Remember, this is the initial side, it's fixed. This is the terminal side, it rotates. And this is a positive angle. Okay, coterminal angles share the same initial side and terminal side. Find add or subtract 2 pi radians, or 360 degrees. Well, this one, remember, we went to here, is 225. Well, if I go backwards, is 360 minus 225. 5 carry the 1, that's 5, 3, 135. So this is negative 135 degrees. Those are coterminal. 225 and 135 are coterminal. Okay? For the positive angle, 13 pi over 6, subtract 2 pi to obtain a coterminal. All right, you have 13 pi over 6 minus 2 pi over 1. In order to subtract, you have to have common denominators. Multiply top and bottom by 6. So I now have 13 pi over 6 minus 12 pi over 6 equals pi over 6. They're coterminal. You could also add pi over 6. So you have 13 pi over 6 plus 12 pi over 6. And you get 25 pi over 6. That's coterminal. I could also subtract 2 pi again. And I get negative 11 pi over 6. Okay, that one's coterminal. That one's coterminal, and that one's coterminal. Same thing here. I have 3 pi over 4 minus 2 pi over 4. 2 pi over 1. You multiply by 4. So now I have 3 pi over 4 minus 8 pi over 4. And you get negative 5 pi over 4. Okay. Or I could take 3 pi, so that's one coterminal, 3 pi over 4, and add 8 pi over 4, and you get 11 pi over 4. I could add 2 pi again and get 19 pi over 4. All right? You can just keep going. I have a negative angle, negative 2 pi over 3, and I add 2 pi, which is 6 pi over 3, and you get 4 pi over 3, and you're going to add 2 pi again, and you get 10 pi over 3. Okay, that one's coterminal, that one's coterminal. Or I could subtract 6 pi over 3 and get negative 8 pi over 3. They're all coterminal. Okay? All right, a reference angle. The reference angle is acute angle formed by the terminal side and horizontal axis. So it's here, it's here, it's here, or in this quadrant, it's here. All right? It's always the distance away from the x-axis, and it's always absolute value. Okay? So your reference angle, 300 degrees. Well, where's 300 degrees? To here. What's left here is 60 degrees. So my reference angle is 60 degrees. It's not positive or negative, it's just 60 degrees away from the horizontal. Okay? 7 pi over 4. Remember, all the way around the circle is 2 pi. If you go in fourths, there's 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8. Okay, so 7/4 is 1, 2, 3, 4, 5, 6, 7. It's right here. My reference angle is right here. Is pi over 4. Okay? 11 pi over 3. Well, let's see. You're talking in thirds. How many are all the way in the circle? Is 6 pi over 3, correct? So if I went all the way around the circle, that's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3. Here I am. But the truth is I went around the circle and then caught up with that, right? Because that's the same as three and 2/3 pi, right? So this is 1 pi, 2 pi, 3 pi, and 2/3. All I did was change my improper fraction to a mixed number. Okay? All right, there's another worksheet out there on for notes, and I'm going to switch and look at that one. Okay? So you think about radians, that this is 2 pi. Okay? This is 0. No, that's just pi. Sorry, I lied to you. That's pi. And this is 0, or it's 2 pi. So this is a half a pi. And this is 1/2, 2/2, 3/2 of pi. Okay, remember this represents radian if it's the same as this. Okay. What did they do here? They divided it again. So this is pi over 2. So this is pi over 4 and 0. And this is 3 pi over 4 and pi. And 5 pi over 4. This we already labeled. Oh, that was 3 pi over 2. 3 pi over 2. And 7 pi over 4. This one, they cut it in how many pieces? 1, 2, 3, 4, 5, 6. So this is pi over 6. 2 pi over 6, which we already labeled, is pi over 3. This is pi over 2. This is 2 pi over 3, 3 pi over 4, and pi. And 7 pi over 6. Oh, we didn't label that one. These are 6. What am I doing? I'm lying to you. Boop, 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 boop. Those I think were right. This is 2 pi over 3. This is 5 pi over 6. This is pi. This is 7 pi over 6. This is how many 6? 7. This is 8 pi over 6, which is 4 pi over 3. 3 pi over 2, which is, that was 6, 7, 8, 9 pi over 6. This is 10 pi over 6. And 11 pi over 6. Ooh. And 2 pi. 10 pi over 6 reduces to 5 pi over 3, so let's do that. All right, going around your circle. 360 degrees is the same as 2 pi radians, which is 1 revolution. So if you're converting these, we just did it, degrees to radians, 250. You got degrees, so your degrees go on the bottom, and the pi goes on top. And then you reduce it. 250 divided by 180 equals 25 pi over 18. And we leave them exact, please. 7 pi over 15 over 12 equals, you want your pi on the bottom and 180 on the top. Pi's cross out. Equals 105 degrees. Okay. 4 radians to degrees is 4 times 180 divided by pi is 6.8. That's not right. 4 radians? That's bigger than 6 degrees. Maybe I multiplied wrong. Yeah, I did. I did something wrong. There you go. 229.18 degrees. Convert 2.4 revolutions to degrees and radians. Well, 2.4 revolutions times 360 degrees. Right, 2.4 times 360 is 864 degrees, or 2.4 revolutions times 2 pi radians equals 4.8 pi radians. Generally speaking, we leave the pi in there, so leave the pi in there, okay? All right, terminal side, the one that rotates. All right, coterminal is, here's my initial side. If I rotate this way and get here, I can also rotate this way. The terminal sides are in the same spot, coterminal. Reference angle, here's my initial side. Here's my angle. Okay, my angle goes this way. This is my reference angle. Right here, that's the reference. All right. I wanted to do this one because I wanted to get to this chart. Angle in degrees to angle in radians. So you're going to take 100 times pi over 180. And you get 5 pi over 9. Coterminal, if this is in degrees, they want these in degrees. So you're going to add 360 and get 460 degrees. Or subtract 360 and get negative 260 degrees. I'm just going to do one positive, one negative. Change that. One positive, one negative. Reference angle. Okay. Remember, it's 180 degrees. 100 degrees brings you to right here. What's left? 80 degrees. So it would be 180 minus 100. Okay. This, they gave me 2 pi radians. I'm going to multiply 2 pi 5 times 180 over pi. They cross out. Equals 72 degrees. Coterminal, they want, since they gave it to you in radians, they want the answer in radians. So I'm going to add 10 pi over 5, because that's 2 pi. You get 12 pi over 5, and you subtract it, and you get negative 8 pi over 5. The reference angle, okay, think about it. 2 pi, 2/5 of a pi. So here's 1/5, 2/5, 3, 4, 5. Okay, so it's right here. It's going to be 2 pi over 5. Okay, negative 390. You're going backwards. Here's your initial side. Negative 360 and 30 more. So let's do my reference angle, because I just did it, is negative 30. Oh, it's not negative, though. It's just 30 degrees, because they're not positive or negative. If I subtract 360 from that, I get negative 30. If I add 360, I get let's subtract 360 again. And you get 330. Go this way is 330. That works. Angle in radians times pi over 180. 390 divided by 180 is 13 pi over 6. And the last one here, let's see. If I multiply by 180 over pi, they cross out, but it's still negative. So that's negative 30. It was in radians. Negative pi over 6 is down here. It's 30 degrees, pi over 6. So my reference angle is pi over 6. If I go around the circle this way, that's 11 pi over 6. If I go this way twice, you have 12, so that's negative 13 pi over 6. All right, that's what your homework is filling in a chart like that. I hope it made sense. If not, watch it again.